A barometer is one of the simplest devices to measure pressure. It consists of a glass tube closed at the top end with the open end immersed in a fluid-filled container. So to calculate the height of fluid in the barometer, we use the equation for hydrostatic pressure such that P1 is equal to P2 plus the specific weight of the fluid times the height of the fluid. So our P1 is atmospheric pressure, which is right here at that dot, and P2 is the pressure at the top of the tube, and this is going to be equal. So P1 is equal to P atmosphere, and P2 is going to be equal to the vapor pressure of the fluid in the barometer. And the difference here between these 2 points is our H, or our height difference. So we're going to look at an example, and we're going to compare a mercury barometer and a water barometer, and we're going to compare that H for each one of them. So to start off with, we need to make sure that we're using all the correct units for the equation. So we have our P atmosphere is equal to the vapor pressure plus the specific weight times H. And here, this is in kilopascals. This is in kilopascals. The specific weight is in kilonewtons per meter cubed. And then we multiply that by m, meters. So this is equal to kilonewtons per meter squared, which is equal to a kilopascal. So now we rearrange our equation for hydrostatic pressure so that we can find the height. So H is going to be equal to P atmosphere minus vapor pressure divided by the specific volume. So let's start with mercury. So our P1 is atmospheric pressure, and we're told that at the top of Mount Elbert, which is where we're looking for our heights, that atmospheric pressure is 57.2 kilopascals. So we're going to write this as that H is equal to 57.2 kilopascals. And if you note in the problem statement, it says assume the vapor pressure of the mercury is negligible. So this is minus 0, and we divide it by our 133.7 kilonewtons per meter cubed, and this height ends up equaling 0.428 meters, or in millimeters, which is what we're asked for it in, 428 millimeters, and we say millimeters of mercury. And as a comparison, if you look at the atmospheric pressure at sea level, that's about 760 millimeters of mercury. Now, let's take a look at water, and we're going to do the same calculations. However, there is a difference because there is a vapor pressure that's significant for water. So our H now is going to be equal to 57.2 kilopascals minus 2.34 kilopascals. And now we divide it, and be careful, you want to divide it by the specific volume of water, which is 9.81 kilonewtons per meter cubed. And when we calculate this is about 5.6 meters, or 5,600 millimeters. So if you do the ratio of the heights, our 5,600 divided by 428, we get this to be approximately 13. So as you can see, the reason that mercury barometers are typically used to measure atmospheric pressure is because of the practicality. It wouldn't make much sense to use a water barometer because it would be much too tall.